Hey, future game changers! When you play your favorite video game, watching your character jump, drive, or fly, it feels like magic, right? But behind every epic boss battle and physics-defying jump is a subject you are learning right now: science. This is why we learn, kids. Today, we're showing you the exact physics concepts used by developers at PlayStation and Xbox to build the worlds you love. Everything in a game, from a flying bird to a falling rock, must obey rules. These fundamental rules come straight from physics. Specifically, Newton's 3 laws of motion. Game developers use these laws to make their worlds feel real and reliable. The very first law they code is the one that brings you back to Earth: gravity. Your character jumps, but they must come down. Game programmers don't just tell the character to fall, they input a precise mathematical value for the force of gravity. Think about it. A NASA engineer uses the exact same gravity calculation to land a rover on Mars that a game developer uses to land a character on a roof. That is the power of physics. But gravity isn't enough. What makes a heavy tank feel heavy and a feather feel light? That's Newton's second law. Force equals mass times acceleration. Every object in the game has a hidden variable for Massachusetts. A tiny marble has a mass of 1. A giant crate has a mass of 100. When the game engine applies the same force, the push from your character, the acceleration, how fast it moves, is totally different. This is how developers create the feeling of weight and realism. Without knowing this second law, every object would move like a balloon. But what happens when those objects hit each other? Rule number 3. Momentum. When your race car slams into a wall, it doesn't just stop. It crumples, spins, and sends debris flying everywhere. That controlled chaos is momentum and kinetic energy in action. The laws governing a virtual car crash are the same laws that automotive engineers use to design real-world safety features. To build a believable world, developers are essentially physics teachers who code their lessons into an engine. Mastering these principles is the first step toward any engineering or coding career. But what about the enemies? Now for the surprising part: biology and logic. If physics handles movement, logic handles thinking. Every enemy, a zombie, a villain, or a digital opponent, is controlled by artificial intelligence, or AI. This AI needs a brain, even if it's digital. The logic rule: if the player is visible, then the enemy chases. If the player runs away, then the enemy returns to patrol. This sequence is based on fundamental logic you learn in school. Where does biology fit in? When AI developers create sophisticated enemies, they study human and animal behavior. That's biology. They are trying to mimic how a real person or animal would react to a threat. Career impact. Understanding logical and biological behavior is essential for AI developers and data scientists. They create the programs that allow self-driving cars to navigate and smart assistants to talk. Learning simple programming logic is the first step to building the next generation of smart technology. It all comes down to finding the patterns. So, the next time you jump a high fence or dodge an enemy in your game, remember, you're not just playing, you're witnessing the power of science and logic in action. When you focus on your science homework, you're training to be an engineer. When you master logic, you're training to be an AI developer. That's why we learn. Subscribe to Why We Learn Kids right now to connect your class to your career.